Select the major product of the following reaction sequence. So in this problem, we are given the starting material, which is an alkene, and we are given a series of 2 reaction steps that this alkene is going to undergo, and we are asked for the final product. So what we should do is start by drawing this alkene and take the time to draw each intermediate step. You may not need to draw every mechanistic step, but any organic intermediate that you can isolate, you should probably draw. So this first set of conditions, MCPBA, this is a peroxy acid. And so this is used to take an alkene and to make an epoxide. So from this first step with MCPBA, that's metachloroperoxybenzoic acid, you will take the alkene and you will end up with an epoxide. And the epoxide will span the 2 carbon atoms that were the 2 carbon atoms of the alkene. And then in the next step, we're adding methanol, which is a weak base, weak nucleophile, and we're also adding an acid catalyst. And so that acid catalyst is what's going to react first. So it might be something like a little bit of sulfuric acid, a little bit of HCl, some kind of strong acid. And so what that's going to do is it's going to react with the oxygen of the epoxide. Because the oxygen of an epoxide or any other ether, much like the oxygen of an alcohol, can act as a base and it can accept an acidic proton. So that will get protonated. So I am going to draw the mechanism for this step because it's going to be important to get an idea of where the reaction takes place. So we have this protonated epoxide, and under acidic conditions, so these are definitely acidic conditions, we can see that by the H+, you will open the epoxide at the more substituted carbon. So the nucleophile will attack the more substituted carbon of that epoxide. So our nucleophile is methanol. So the methanol, if we draw it here, is going to attack, here's a primary carbon, this one's secondary, so it's going to attack that secondary carbon, which breaks open that ring. And so if we follow our arrows here, so there's that 5 carbon atom backbone we started with. We've attached the oxygen of the methanol to that carbon here. So here it is. It still has a hydrogen attached to it and a positive charge on that. And then the end carbon atom still has a bond to the OH. And so we can see if we just do one more proton transfer, so we should have plenty of methanol around to take that extra proton. And so if we take that off, we're going to see that we get the molecule that's shown as A. And so that is the final product of this series of steps.